Hello, and welcome to this quick overview of LOGIO's performance monitoring and centralized log data solution. LOGIO is a software-as-a-service solution based entirely on open-source software. In this demo, we're going to focus on Windows systems. Keep in mind, though, that LOGIO can be used to collect metrics and log data from other operating systems, as well as network devices, such as routers and firewalls. LOGIO's visualization portal is based on the open-source tool Grafana. For this demonstration, our first step will be going over to LOGIO's URL and logging on using the demo credentials. Right after successful logon, the main portal is presented. We'll start this demo by selecting the Windows Systems Monitor using Zabbix. The monitoring dashboard is structured in 5 main sections: Summary, Performance, Network, Critical Processes and Problems. The Summary section will display the server's inventory information and includes a widget for the problems detected in the particular server being displayed. Each server being monitored can be easily selected from the top left of this page. Under the Performance section, we start seeing relevant metrics collected by the agent and stored in the monitoring server. The metrics collected and displayed in this section can be grouped into the following categories: CPU and processes, memory, and disk operations. Each widget can be selected individually for a better visualization. So, for example, selecting the memory and CPU widget will maximize these 2 metrics in a screen for a better analysis. Areas of interest can be selected, and the time range will adapt according to a selection. In this case, we're focusing our attention on high CPU utilization values. Once the area of interest has been selected, we can go back to the dashboard and keep investigating this issue. High CPU values seems to correlate with high volume of disk output operations. Getting to the bottom of our investigation will involve which process or processes is causing this spike in CPU and disk load. This is where monitoring individual processes comes handy. We can now unfold the Critical Processes section and evaluate the same CPU and disk metrics for individual processes. Selecting the CPU info widget for a better observability, we can easily identify 2 processes, in our case, causing these spikes in CPU. Similarly, selecting the disk operations widgets will help us to correlate the CPU usage and the disk access operations. The last section we'll have a look at is the Problems section. Here we can see events or conditions that have generated an alarm that might require our attention. Alarms are categorized and classified by severity. In this section of the dashboard, we can also acknowledge an event, and the tool will allow us to add information about the user who acknowledged the alarm. We'll move now to the log data analysis dashboards. Again, the context in this demo is Windows systems alone. For Windows systems, the log data collection includes a summary or global overview of the data collected, Windows Event Logs, System, Windows Event Logs, Application, Windows Event Logs, Security, Network Activity, DNS Activity, Process Activity, Windows Registry Operations, and Windows System Files Operations. In the Summary section, a global overview of logs received and processed is displayed. Along with the histogram and messages per log source, the received number of logs per severity level is also displayed. At the bottom of this summary dashboard, summarized information about top processes executed and network connections can be found. We can start applying filters from the top left of the page that will apply to and will update all the widgets in this dashboard. So, for example, we can apply a filter to display information for messages with a specific severity level. In our case, we'll select a log level of error to start analyzing which Windows systems and log sources are reporting this condition. Once the filter has been applied, we can start our investigation by going directly to the log data related to the Windows event logs with this error condition. In our case, our focus should be on system logs. On the top right of the page, a new menu can be opened and the Windows event logs system can be selected. This will open a new page, and the filters previously selected and applied will be carried forward. In this new window, we can easily determine which processes are causing the error condition. We can see, for example, that the Microsoft Azure synchronization process is having some issues. The table at the bottom of the page includes all the required details to determine the root cause of the problem. In our case, the logon credentials used to connect to the Active Directory services in Azure are not working. We could also analyze network-related events started by the synchronization process. A good starting point would be having a look at DNS requests. Selecting this option in the landing page will take us to all the DNS activity logged by each server. As part of this visualization, the system processes making DNS requests will be included. We just need to filter, using the zoom symbol, selecting the process that we want to analyze, and all the widgets in the dashboard will be updated. As we can see, the process is trying to resolve hostnames and Windows.net domain, as expected. In the table, at the bottom of the page, we can also confirm that the DNS resolution was successful. We'll finish this demonstration by having a look at log data related to processes and registry keys activity. This analysis is especially relevant from a security point of view. It will allow us to determine which processes or applications are running in our environment, and it will also provide information on detected software packages and vendors. Every time a new process is started or terminated, a log entry will be recorded. Along with all the summaries included in this dashboard, the table at the bottom of the page will include the details about the user account under which the process was started or terminated, the full path to the process image, etc. This dashboard also contains a table with all the process images executed and their file hashes. The field in this table containing the file hash includes a hyperlink to the VirusTotal website. The file hash will be submitted to this website for scan and scan results. A new tab in our web browser will open, showing the results of the file scan. This table and its related link will allow us to identify malicious code and check hashes against all the databases included in VirusTotal.